We will start with considering a hypothetical situation. I'll create a separate folder for that. And let's say we call this teamwork. And let's imagine that, let's say, we will have we'll build our infrastructure in a team of more than one person. Let's say we'll have a person, his name will be Joe, and this folder over here in this terminal window, and let me color it into red, will play the role of Joe's computer, of laptop owned by Joe. I'll have a separate window, and let's say second, the second team member will be, I don't know, Jen. And this terminal window will represent Jen's laptop. And let's color it, and let's color it into some different color. 1 second. Yeah, very good. Are these two screens visible enough? Because it's quite we'll be switching between them very often, so I want to make sure you can read them clearly. Okay, and let's say they found a valuable code somewhere on GitHub and decided to reuse it. So what will Joe do? He'll clone our project, and same thing will do Jane. She will clone our project as well. So at this point, both of them have a copy of our code base. Let's say this. Joe creates a branch, and let me open this in code editor on behalf of Joe and make some changes. So here we are. We'll have both Jen and Joe, but let's say, just to speed up things, I'll comment out everything and keep only a VPC, just a single resource, AWS VPC. So we don't have to wait until it's supplied and until everything is created, not gateways and all these things. We don't need this for this demonstration. Let's say Joe pushes it and runs Terraform apply. So it wants to create one resource, so that's our VPC. Let's hit yes. So now let's say Jen wants to wants to make some changes in this VPC. Checks out the branch of his colleague. Opens again from your laptop, from your device, and let's say adds one more resource. So what we are, sorry, wrong folder, this one we're supposed to have. And let's uncomment the resource. And before I run Terraform plan, who can guess what changes we are expecting and what changes will happen actually? And it's a tricky question, keep in mind. And don't forget, both these two colors of two terminals in this scenario demonstrate different laptops, different computers. So Joe have applied his changes, Jane has pulled his branch, made her changes on top of that, and reapplied. So perhaps we'll see that one more resources will be created. Let's verify this. Yeah, we have multiple assumptions in the chat. Terraform state will complain. No, it will not complain. For some reason, it is trying to create a VPC again. So it's not aware about changes made from this part. Why is that? Because perhaps you've seen this file already, hopefully paid attention to it. Information about actual resources that have been deployed and that Terraform should track located in this terraform.tf state. And here we are. We have resources, data source, and resource AWS VPC. And to give like clarity on this, let's comment this out again and run Terraform plan again. So this time it will suggest that it needs to create only one resource. And once again, why is that? Because both these deployments, both these separate, I would say, colleagues have their own version of Terraform TF state. Joe has applied his own Terraform from his laptop. He created his file for himself. Jen, he's not yet applied. She doesn't even yet have this terraform.tf state. This means her Terraform on her laptop, is not aware that something has been already created and will basically try to create everything again from scratch. And we can do the trick. We can copy this Terraform TF state file, paste this, give it to Jen, and when we run Terraform init and Terraform plan again, now it says no changes. Now it discovered everything that was applied previously. And the question is, When we cooperate, when we perform active development, how do we make sure this Terraform TF state is synchronized across everyone who is working on this project? And the answer is, as Iman mentioned in the chat, store this file remotely. And what remote storage is best for us? Remote cloud storage. We can create an Amazon S3 bucket, an object storage by Amazon, and put this state data, this TF state file, into this remote state bucket, into S3. And let me demonstrate how to do this. So I will delete this TF state, and in our provider configuration, we will go and add the following block. Sorry, forgot one more thing. Should be like this. And let me log in to Amazon and create a bucket. So we'll go S3. I have, for example, let me take one of my previous buckets. So you can always press like this, create bucket, provide a unique name for the bucket, and basically create it. But I will reuse one of the buckets that I had previously. This one I use for remote state. And what this essentially means? It means that Terraform will initialize itself and store this TF state file not locally, but in a bucket called Terraform remote state ABC123 ABC, in a file called terraform.tf state in the region, and the region of this bucket should be US East 1. Let's try this. So we will need to run Terraform init one more time. It will tell us that, hey, I've discovered that you changed your backend configuration. Do you want to migrate the data? We'll say yes. Okay, very cool. Now it says Terraform successfully initialized. And what we'll do next is check what actually happened. And when we go to S3, when we open the result of our buckets, sorry, a lot of things from my previous attempts. Let me clean them up. We'll have the same terraform.tf state. Can we open it? Exactly the same file that has this AWS VPC, this time stored in terraform.tf state. And let's configure these git add provider.tf emit -m configure remote state and push. So getting back to Jen, we have deleted our Terraform TF state. There is nothing yet here, and there is nothing yet in this provider configuration on your side. It's previous state. We haven't yet pulled this, and when we run Terraform plan now, it will attempt to create a VPC once again. Here we are. And when we run git pull and fetching the latest changes of provider TF, now it is pointed to the remote state. When we run Terraform plan from here, actually Terraform init. When we change something in our backend, we always need to run Terraform init first. This bucket, yeah, and the question in the chat, is it mandatory to have this bucket as public, or we can restrict access to subset of accounts? This bucket should not be public, and even though you see this memo that objects can be public, this does not mean that objects are actually public. That's just a reminder from Amazon that public access is not that blocking of public access is not enabled. That's slightly different things, but the object itself is not public. It's visible only to me as an owner of the AWS account. And of course not. You should never expose this file publicly. No one should know what runs within your infrastructure except you and your team. We've run Terraform init. Let's run Terraform plan. And it says the infrastructure matches desired configuration. Very good. That's great. But next question that we might have. Let's say we've agreed on that. We started to use remote state, and all changes are synchronized. But imagine hypothetical situation. We have one VPC here with 10.0/16 TIDR range, right? And let's say second VPC right now, actually it's the same VPC, right? Let's imagine this. Jen decides to change this VPC to 10.1/16. And Joe decides to change this to 10.20/16. Let's save both of these files. And let's say they fail to communicate with each other, working for some reason like miss a daily meeting and not aware that both of them doing these changes. So Joe runs Terraform apply and Jen runs Terraform apply. So both of them proposing quite similar changes. One resource to destroy it and one to add means VPC will be recreated. But the only difference is Joe will change the VPC to 10.20 and Jen will change the VPC to 10.1. So when we hit yes simultaneously, what will happen? Yes, Boris.
Whoever gets there first.
Actually, there will be kind of whoever gets first will start landing these changes. However, second person will also pick up and continue changes as well. And this will be kind of, you can never predict when this happens.
So I'm not sure if there's some sort of a semaphore built in.
No, there is a measure to prevent this this collision, and this is what I'm going to demonstrate. But if we don't have this enabled, I would say unpredicted things could happen. So I cannot guess. Maybe a VPC will be deleted and second will error out. Let's see. Okay, looks like they managed to somehow land it, and most likely this will be our final result, 10.1. So they did not have a collision now. But let's say this one run Terraform apply and this one run Terraform destroy. Terraform destroy. Yes. Yes. It says destroyed. It's we did not manage to error out, but anyways, that's something we need to avoid, right? So how we can do this? There is a feature called log file. What it is doing is that it's also a remote file, but this time in a database. And this remote file, when it's created, it means someone is applying something. When there is no this file, when apply finishes, this file gets cleaned up. And this is also done via provider config. And this file is stored in a DynamoDB table. Terraform remote state. Okay, very good. And let's also create this table. And it must have partition key with the value ID. That's a requirement of Terraform. Terraform will look for this partition key. Let's press create table. Sorry, not ID, log ID. Let me create it one more time. So we need to wait a couple of seconds while it is creating, and we can use this time as an opportunity to ask questions. Yes, Piyush.
So I have a quick question, like when the log file will be enabled to these two teammates, I mean, during which part of the execution this will be enabled?
Let me demonstrate this, and I'm sure you'll get the answer to this question.
Sure, thank you.
So, yeah, let's double check everything. Terraform remote state. We've created this table. Let's also commit it. Status git add provider.tf git commit -m configure log table git push. And here we'll run git pull. So let's run Terraform plan one more time. And we have changed our backend configuration. We need to run Terraform init one more time. And let's run Terraform plan. We need to change something, I suppose. So this was Joe. Let's return back to zeros here. I will run Terraform apply. It will say it's gonna delete and change back to 10.0.0.0. And here we run also Terraform apply. And let me show you what will happen. It says error acquiring state log. And what this state log means, it means there is someone already who is planning to run these changes. So let me run this apply first. I'll hit yes. And only after that we can get back once this operation is finished and nothing is in progress. Now we can run Terraform apply one more time here. And it is giving us this. It is allowing us to make this change. So how does it works? If we go check this table, we'll see that it has this terraform.tf state file line. This means it's currently locked. And other terraforms on other machine will check this table first and make sure there is no such log, such line in this database. And when we run Terraform apply, when it's applying, making changes, and successfully exiting, this log will go away. Nothing else here. And this is how we configure, first of all, a remote state. Yeah, so when our laptop, for example, goes away, stolen or broken, entire infrastructure does not go away with it. At least information about how infrastructure is managed. And when multiple people trying to apply different changes for the same infrastructure, they will not step on each other's toes. So let's push it and create a pull request so we can merge our changes. Actually, there is something else we need to do. We need to return everything to the original state. Let me show it to you. So when we create a pull request, configure remote state, we've commented out a lot, right? There was a separate commit where we disabled everything, yeah, for the sake of this demo. And we don't want these changes, obviously, to go into our main branch, right? This was done only for me to demonstrate how it works. Let's use git rebase to delete this commit so that we have full changes that we've had before. And it was add initial changes. So I run git rebase -I at -3. Instead of pick, I choose D, which stands for drop. Simply delete this commit. I save. It says successfully rebased. I force push. And let me refresh that. Here we are. We no longer have these changes. This commit, this atomic change that we've done simply goes away and like it never happened. So when you have some commit that you think this change is not good, you think this change not needed anymore, you don't have to create one more commit on top of it. But instead, it will be significantly better, more clear, and more professionally looking if you just drop commits using interactive rebase and force push and override your feature branch. Yes, Boris, your question.
Yeah. Is it not a good practice to use git amend, but to rebase instead? Rebase is better.
You can use git amend, but amend only edits your last commit.
Gotcha.
But if you want to delete commit that happened several commits ago, you are not able to use amend.
Gotcha. Understood. Thank you.
It's like, it's like using spoon versus using fork, versus using something else, right? Sometimes there are situations when rules force you to use some certain tableware, right? But most likely, most often, it's just a matter of preferences. Same here. If you think commit works better for your specific use case, for your exact situation at the given moment, feel free to use amend. If you want to use, if you think that rebase works better, you can use rebase. But what I'd say is, in this analogy, in this setup, creating additional commit on top of your previous commit to return what you had before, at least for me, it is equal to not using any tableware and eating with your hands. So try to maintain clear history and use amend, rebase, a combination of it, and your Git skills will improve significantly, and your Git history will be significantly better, easier to read, and you'll take advantage of these meaningful changes that you have in your Git.
Thank you for the explanation. Yeah, I just wanted to hear it from you. How you do it?
I use both. Depends. Okay. Yeah, Ramraj.
Hey, Vladimir. So sorry, there's a prod call going on. I'm on and off. If I'm asking a question that has already been explained, my apologies. I see that we have created a bucket, and then we have set up the file name as Terraform TF state. And every time we perform any Terraform action, that state file gets updated. I also see that you have created a table for the log file. Is there any other way other than using DynamoDB that we can save the log file? That is the only way?
Yeah, there are numerous ways for storing log file. In AWS, DynamoDB is the most the most widely used one. Terraform state log. Let's see what documentation say for us. It has plenty of options.
Okay.
Documentation for each backend, available backends. So you can store your backend in console. It's another tool of HashiCorp. let's go here. Here, all of them are different backends. For example, in Azure by default supports file locking without DynamoDB, so we can lock a file directly in Azure storage. This means like there is no need to create any additional tables, and it all depends.
Okay, it depends on our use case, I guess.
Yes, that's
Thank you.
right. Okay, so we no longer need this. Let me recreate a terminal. So we have created some resources to maintain this workflow, at least DynamoDB table and S3 bucket. But why don't we automate them as well? So we can do this. Why not? And let me demonstrate you how we can do this. Like automate everything as much as possible. I'll create a separate folder and call it remote state. And I will explain later why I am creating this separate folder. Let's have a provider.tf. Let's have main.tf. And the resource will be S3 bucket. I forgot how to write it. Let's consult with documentation. Okay, very cool. Let's omit text for now. Let's call it remote state. And the name of it is Terraform remote state. And let's create a DynamoDB table. Yeah, examples are slightly complicated. We'll need to remove a lot of things. State log. Name is Terraform remote state. Provisioned, read capacity 1 and 1 will be enough. Cache key log ID. Range key, we don't need it. Attribute log ID, type S. The remaining things are not needed. But when we run Terraform apply, it will give us an error saying Yeah, I forgot to add provider configuration. 1 second. When we run Terraform apply, it will give us an error saying the bucket and the table already exists. And what we can do here? The naive approach is to simply delete this S3 bucket and recreate it using Terraform. But what if we already have some data there that we don't want to lose, right? If recreation of a resource doesn't work for us, what can we do? There is a command called Terraform import. And what it is doing is that it takes the existing resource and connects it to Terraform. So what this command means? It means like Terraform import, the command itself. We should provide the Terraform resource name, basically this field, and the name or identifier of the actual resource. Let's try this. Non-existing remote object. Okay, let me check the name of. Yeah, it's Terraform remote state. Terraform remote state. Yeah. Very cool. And same thing we'll do with bucket. Okay, very cool. And when we run Terraform apply, yeah, it will add, it wants, okay, we need to change some things. So it should be big ID. ID. Let's try one more time. Very cool. Yeah, it says no changes. It says everything is good and everything is fine. And let's also configure the remote state for it. Provide the TF. Let's take this configuration and incorporate it into our Terraform remote state. Terraform init. It's gonna override. Yeah, and we will need to change these to, for example, like remote state.tf state. Yes. And run Terraform apply again, just to make sure there are no changes. Okay, let's imagine we finished for. Let's imagine we finished for today. Run Terraform destroy for infrastructure. Delete everything here. delete everything. Oh. Delete everything, destroy everything here. And we got an error. Can anyone guess what has happened? Why we was not able to delete the item after we run Terraform destroy? Yes, Boris.
No, I thought I knew. I don't. I'm sorry.
Okay, so we have, yes, Sabina.
Did we kind of activate prevent destroy?
No.
Did we tell it to true?
Nothing prevents destroy.
Okay.
Okay, let me give you one more hint, and hopefully someone has an every commandment. This folder, remote state, we used it to automate creation of S3 bucket and DynamoDB table, which is used to store remote state and to log the remote state using DynamoDB table. We are creating these tables themselves using Terraform. But we also rely on them to create themselves at the same moment. Yes, Boris.
So it's in use essentially?
It's so we create a table which is Terraform remote state, right? We've created, and previously we've imported what we created manually. But our provider expects this Terraform remote state to be for us already there. And what happens when we destroy? We delete this table and we want to unlock the remote state. This means Terraform will go to provider to whatever specified, but this remote state is already gone. It was destroyed by itself. Yes, Sabina.
So does that have to do with the fact that the DynamoDB and the whole configuration is stored locally and not remotely? So we need to like pick it back and set the default back to local before we destroy.
Yes. And let me create some pictures so it will make even more sense. So we have our code. Which one is good? Okay. We have our code that creates a DynamoDB table. So it creates it. But in order to create it, it needs also to have a lock, to obtain a lock from this table. So it's trying to, I need to create this table, but before I do this, I will obtain the lock from the table that does not exist. And same situation vice versa. When it destroys the table, it destroys this lock table, and then it is trying to release the lock from the table that's already been destroyed. It's kind of chicken and egg problem. And let me run Terraform apply again and demonstrate this further. It says resource not found. probably something wrong with our Dynamo table. Yeah, and indeed, if we refresh, go to tables, there is no more table anymore. And S3 bucket, probably, yeah, it's still there because it was not deleted, because it was not empty, right? So that's fine, that's okay. But anyways, what should we do? We should not use remote backend in the case of remote state configuration. So it's not able to create DynamoDB table and use this DynamoDB table for managing its own state at the same time. So what we'll have instead, how we're gonna share this Terraform TF state file, is that we're gonna commit it to our Git repository. And in case someone wants to make changes in our remote state bucket and remote state DynamoDB table, he or she will just pull this into our Git, make proper changes, apply, commit TF state file as well, and have it stored. That's the only case when we should have Terraform TF state in our Git. All other cases, we'll store them in S3 locally, or in S3 remotely. It says 2 files to be created. We already have S3 bucket, so let's re-import it again. We just, yeah, because of these experiments, we've lost our previous state. So S3 bucket okay to import. DynamoDB table will recreate because it was deleted. Now let's commit everything. So I don't see terraform.tf state in my Git because previously we've added it into our Git ignore. So you'll need to explicitly write the path to it and add -f option to it to make it like as an exception. And remember, we are committing Terraform TF state only as an exception for this case where we are managing our S3 bucket and the DynamoDB table for our remote state. And I also forgot to add a new line. Let's fix that. Okay, so let me do this. So the remote state folder, you don't have to run Terraform destroy again and again. It is okay to keep this bucket and this DynamoDB table. It will not cost too much. The rest of the infrastructure, don't forget to run Terraform destroy as usual. With that, that's all for today. And let me know which questions